Okay, in this video I'm going to show you how to plot and map out the magnetic field around a bar magnet. Right, the most famous way, or the way that you probably remember most, is to use this stuff, iron filings. Iron filings are just literally tiny, it's like iron dust in a way. It's like a lot of iron that's ground down into tiny little pieces in like a little pepper pot, and if we sprinkle the iron filings around the bar magnets, I've got this see-through Tupperware lid because it makes it a lot easier to remove the iron filings after we've finished the little demonstration. But as we can see, if we sprinkle the iron filings around the region of space around the bar magnet, they'll align themselves and show that characteristic magnetic field pattern. Now, what we're seeing here, or the reason why we're seeing this, is because, like I said, explained in the previous video, when you put a magnetic material like iron, cobalt or nickel, a piece of iron, cobalt or nickel in a magnetic field, it itself becomes a magnet as well. It becomes magnetized, and each of these individual pieces of iron are becoming magnetized. They're turning into tiny little magnets, so they are aligning themselves with the magnetic field due to the bar magnet. Okay, now that's a bit messy, so I'll just put that to one side. Now the way I'm going to show you now is much less messy. Okay, we're simply going to use our friend the plotting compass. Now, just like a tiny piece of iron in a magnetic field will become a magnet, we have a plotting compass. Now remember, the needle of a plotting compass is itself a magnet. It's a piece of magnetized steel. So as we can see there, we can see it pointing north. That's because it's aligning itself with the Earth's magnetic field. And if you remember from the previous video, that's the direction of north. However, if we were to put it close to the bar magnet, the bar magnet's magnetic field takes over because it's obviously stronger within the region of the bar magnet. And as we can see, the magnetic field aligns with the needle on the compass. Okay, now we want to draw this, we want to plot this out. So we're not going to use this fella because he's a bit big. We're going to use this plotting compass. Okay, exactly the same as this fella here, except on a smaller, more manageable scale. So if we place this into the magnetic field, now this is the procedure you need to describe on your flowchart. Okay, right. We take the bar magnet. We take the plotting compass, and we place the plotting compass close to the North Pole. Remember, blue is south, red is north. Right, you place a dot on the north side, the north pointing side of the needle on the plotting compass. And then you move the plotting compass so that the south side of the needle is on the dot you've just drawn. You then draw another dot and repeat the process, each time moving the south pole, the south facing side of the needle to the dot you've just drawn. Now doing it this way, as you can see, plots out the magnetic field line within this region. Okay, so just simply joining the dots now will give us one of the field lines. Now if we repeat exactly the same process, placing the plotting compass close to the North Pole, put a dot on the north facing needle, side of the needle, move the south pole, sorry, move the south, yeah, the south part of the needle, south facing end of the needle to the dot you just drawn, and repeat that process. Then we can plot out another magnetic field line. Now these are the field lines of the fields due to the bar magnet. Again, let's join the dots. As neatly as we can. And we get another field line. Now we can do exactly the same thing on the other side. So a dot, move it, a dot, move it, a dot, move it, a dot, move it. And as we can see, the field lines leave the North Pole and loop out and come back to the South Pole. So again, joining our dots as neatly as we can, we get this sort of carry on. Now, what happens here? Same thing, we can start at the North Pole, put a dot, move it, 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 put a dot. So facing or moving directly away from the North Pole, the field lines do this. So what's going to go here? What's going to happen here? Dot, move it, dot, move it, dot, move it, dot, move it, and so on. All the time, the needle of the plotting compass is aligning itself with the magnetic field of the bar magnet, wherever it is in that field. Okay, now we can carry on. We can carry on and map out the whole of the magnetic field. Okay, and it will look something like this. Okay. Cheated a bit there, but that's if I'd have carried on mapping it out with this plotting compass. But you see how well I've cheated, because wherever I put the bar magnet, wherever I put the plotting compass, it does in fact align itself perfectly-ish with the field lines that I've drawn. Okay. Now, one last thing. Magnetic fields are vector fields. So if they're vector fields, they have magnitude or strength or size, but they also have direction. Remember, all vector quantities are quantities that have size and a direction. So magnetic fields show us the direction of the magnetic force on a magnetic pole. So which direction is it? Right, you should know from, I think, year 8, that magnetic field lines always go from north to south. Now, if you remember, the red is always north, the blue is always south. So if they always go from north to south, then we can draw our arrows like this. Okay. So there you go. The magnetic field around a bar magnet, slightly less messy than our iron filings method. Thank you.